In a world where nothing is certain, there's one man who can determine any distance thrown his way. His name is Doc Opp.
Oh my God, is that Doc Opp? You're my superhero! Measure how far away I am!
I'd say about 27.21875 inches.
You can be like Doc Opp with the help of the new IR optical distance sensor. Now, let's learn about this amazing product from an interview with our professional engineer Michael, an undergrad student that just finished up his semester in ME 3870 measurements class.
So by conducting this experiment, we hope to calibrate a nonlinear sensor using methodology used all semester in lab.
When asked about the experiments and operations, this is what Michael had to say.
This sensor works by emitting a ray of infrared light from one side. The light comes in contact with the object, and the light reflected back to the sensor with an intensity is converted to a voltage. This voltage is associated with a particular distance range, so the user knows how far away the object is. A tape measure was placed on a flat surface, and the distance sensor was mounted on a box. For the static calibration measurement, they were taken from 1.5 inches to 12 inches away from the sensor in increments of a quarter of an inch. For the dynamic calibration, two boxes were placed one in front of the other, and data was collected as the first box was removed from the second box. This sensor works effectively from 1.5 inches to 12 inches, or approximately 4 to 30 centimeters. And now for the specific details regarding this beautiful sensor. So the resolution error came out to be about 0.0017 centimeters for our data acquisition system. The hysteresis error came to be about 0.2250 centimeters from our static calibration. Now our linearity errors, those were the biggies. We had negative 1.9723 centimeters and negative 1.4403 centimeters respectively in linearity. Now moving on, our tape measure had an error of about 0.0794 centimeters. When adding all that up together, you get a design stage uncertainty of about 0.0794 centimeters approximately, and a total error of about 2.4539 centimeters approximately. Well, we found out that our sensor was actually nonlinear, so it was expected that our error from a linear regression function is where we're experiencing all of our largest error. So researchers found that our sensor was a first-order system with a bandwidth of about 34.867 Hz, and our dynamic calibration was sampled at about 20 Hz, but the sensor's actual sampling rate is about 60 Hz. So in conclusion, the sensor has a bandwidth of about 35 Hz and a total error of about 2.5 centimeters, which isn't great, but I'd still buy the product anyways.
My name's Doc Opp, and I approve this sensor.